All right, POE, we're here going to do our first moments practice problem. And actually, I just want to briefly at least look with you. Problems 2 and 3 are much more straightforward, much more simple. And so you might want to do those first. The third problem actually leads into our next topic of trusses. And so you might want to look at that one last. But just as a reminder, at A, we have a support that's a pin support, and so you can put in 2 reaction forces and one reaction force at B for a roller support. But let me just take you through how to do this first problem. And the key for this is that we're doing the sum of the moments around the pivot equals 0. And so each of these turtles is going to cause a moment. And over here we have Raphael, and he is going clockwise, so he's causing a negative moment. Leonardo here is going clockwise and also is going to cause a negative moment. Michelangelo will cause counterclockwise, so it's positive. And I'm sorry, this is Donatello, and this is Leonardo, and Leonardo will cause a positive moment as well. And so we have the mass of many of these guys. This guy is 50 newtons, this guy is 47, this guy is 29, and then this is the force of Raphael, which we do not know from the problem. So let's add up our moments. So we have the moment of Leonardo plus the moment of Michelangelo minus the moment of Donatello minus the moment of Raphael equals 0. And again, we're calling these two negative here because these two are negative because they cause a clockwise rotation. Okay, and so then now we plug in our numbers. So for each of these moments, remember a moment is equal to a force times the distance perpendicular. And so the force for Leonardo is 50, and his distance is 4 meters from the pivot. His distance is 4 meters. Michelangelo's distance is 2 meters, so plus 47 times 2 meters. Minus Donatello is 4 meters away, and so that is 29 times 4. And then minus Raphael is 7 meters away, and his force is unknown, so I'm going to do FR for Raphael's force times 7 meters equals 0. And so you get 200 plus 94 minus 116 equals, and if we add this to the other side, 7 times the force of Raphael. And so 7 times the force of Raphael equals, if we add all those up, we get 178. And so the force of Raphael is 25.43 newtons. And then we know Raphael's force in order to balance. Of course, if he weighed more, then it would be rolling this way and rotating this way. If he weighed less than that, then they'd be getting lifted up. All right, and that should help you out.